Hello. So we are going to discuss this question today, which is called as find the median from a data stream. The question is pretty straightforward. We are going to be given some numbers. We need to add those numbers into some particular something, and we need to find the median of that at any given instant of time. So first we need to know what exactly the median is. So if we talk about the median is nothing but a middle of sorted list of integers. So suppose if we have these numbers, which is these numbers. So basically, the middle value is said to be called as a median in a sorted way. So it's that value which basically divides the array into two equal halves. So if the number of elements is odd, it is going to be a middle value, and in case the number of elements are even, then it is nothing but the mean of the mid two values. Like in this case, it would be uh, like 21 plus 23 by 2, which is 22. So median is 22. So the main takeaway from this is the median can belong to the set of elements, or it may not. So if the number of elements is odd, it will belong to the list which is given, and if the number of elements is even, then it will not belong to the list of integers which is given. So this is about what is median. So if we talk about what is given in some sites, it would be something like this way. So like by stream, I means that if 5 is given, if we just assume that only 5 would be there, then the answer would have been 5. If like the next number which is added is, let's say, 15, now the median is going to be 10, which is nothing but 5 plus 15 by 2, which is 10. If one more number is added, now the median is going to be 5, which is a middle value. How do we got it? If we sort it, we got 1, 5 and 15, and the middle value is 5, and so on and so forth. So if we see some algorithm here or on some other platforms, you will see that they are, I don't know why, but they are going in a very big way and following very reducted approach. And I think many corner cases are also not included here. So if we, I mean, even if we see their STL approach, in that also if we go, then in that case also, I think they are just like not considering all the cases, and they are just writing reductant and bullshit code. So we try to solve this question by using the STL and try to submit it. It is very simple. So the basic idea which we are going to talk is, the median is that value which divides the array into two equal halves that we understood. So what we're going to do here is we will take one max heap and one min heap, and as soon as any element is added, like any element we need to add, we put it into the max heap. And then if, like, after putting it into maxi, we try to have, like, since the median belongs to the middle element, we always have to make sure that the size of the min heap and the max heap should be equal. So what we do initially is, whatever elements come, we'll push it into the max heap, and then we will remove that element and push it into the min heap. Then we check if the size of the min heap is more than the max heap, then we push it the I mean then we pop the element from the min heap and push it into the max heap. So like we can understand something like this way, that, so assume something like this way, that there is going to be a max heap, and let us say there is going to be a min heap. So we want to make sure that the size of this max heap is equal to the size of the min heap. That's what is our main intention, that the size of both the heap should be equal. So if they are equal, we can just take the top elements of both of them and take the average of that, and then we can return that value. That's our main intention. So whatever element is going to come, we just initially put inside the max heap. So suppose initially, like the example which we was taking, so initially, let's say we put inside the max heap, let's say 5 comes, then we insert 5 into the max heap. Then we will remove this 5 and put it into the min heap. Why I'm doing this, I'll tell you. So we'll put it inside the min heap. Now, since we are saying here that the size of min heap is more than the size of max heap, we'll remove this one element only and push it inside the max heap again. So that's how we insert it. That's a simple idea. So whatever elements come, you push it into the max heap, and then you remove one element from the max heap and push it into the min heap. And as soon as we see that the size are equal, we'll not do anything. So let's say now 10 comes. So then in a max heap, the 10 would be at the top, and then 5 would be like below it. So we have inserted 10. Now what we do is we'll remove one element from the max heap and put it into the min heap. So if you remove one element from max heap, it would be consisting of nothing but 5 and 10 would be removed, which we are going to push it here. So now at this instant we see that the max heap is equal to the size of min heap. We don't do anything. Now if you want to find the median of these two numbers, we have to just say pick up the top two elements, take the average, and we are done. So in this case the answer is going to be 5 plus 10 by 2. So 5 plus 10 by 2, and then we are able to get the answer. But since we can get the answer in fractions, we can just take 0.4 and the answer is going to be 7.5. So let's try for one more value. So suppose now comes, let's say, 15. Now, as we discussed, like as we insert 15, since it is a max heap, then 15 would be at the top and the 5 would be at the bottom. So now again we do the same thing, that we will remove one element from the max heap and push it inside the min heap. So after this, it will be consisting of this thing. Now we are saying here that the min heap size is more than the size of the max heap, right? So what we do is we'll remove one element from the min heap and push it into the max heap. So why we are doing this, I think you got it by now, that we want to make first the size of both the heaps to be equal. But in case the number of elements is odd, then the size cannot be equal, and in that case we are making sure that the size of the max heap is going to be greater than the size of the min heap by a factor of 1. So in this case, we'll remove the value of 10. We push it the 10 here, and we got 10, 5, and 50. So now if somebody will ask me to give the median would be nothing but the average value of 10 and 50. So overall the answer which we're going to get is going to be 10 plus 15 by 2, which is going to be 12.5. So the answer is going to be 12.5, and that's how we are going to do it, and this is just we need to do it, nothing else we need to do. So as planned, we just need to create one max heap and one min heap. So let's get started. So first I'm going to create one max heap. So I'm going to give the name as this. Now we need to create one min heap as well. So we have created one max heap and we have created one min heap. So by default, the if you don't mention anything here, it becomes a max heap, and the second line will create one min heap. So as we discussed, what we have to do is any element comes, we just need to push it into our max heap. So what we're going to do is we just say max underscore heap dot push. What we need to push the number which is coming, and then what we planned is we need to remove one element from the max heap and push it into the min. So we do the same thing again, that we'll remove one element here. We'll say in x is equal to um, this max underscore heap dot top, and then we will remove this element from the heap, and then we need to push it into the min heap. Then we need to push it into the min heap. Then we'll just say min underscore heap dot push x. Now, as we discussed, we need to just check if the size of the min heap is more than the size of max heap or not. So we'll just check if min underscore heap dot size is more than max underscore heap dot size. If that is the case, we need to remove one element from the top and push it into the max heap. So we do the same thing, say max underscore heap dot push. What we need to push is min underscore dot top, and then we just need to pop the top element. So we'll just say min underscore heap dot pop. That's it. So after this, our function for this is done. Now to find the median, as we discussed, if the size min underscore heap dot size is equal to max underscore heap dot size, if both of the size are equal, then in that case, as we discussed, we just need to take the average of the top two elements. We'll just do the same. We'll do min underscore heap dot top plus max underscore heap dot top divide by 2. Since the answer could be in fractions, so we can just divide by 2.0, and yeah. So if that is not the case, I mean the size is not equal, then it means that our answer would be on the top of the max heap. So in this case, we'll just return the top value and we are done. So this is just the basic logic, basic code. I don't know why in other platforms they are considering a lot of cases, a lot of big codes and confusion. The main idea, the main logic is just this. Let's try to first run it. So where it is giving wrong, let's try to see. First we insert inside this, we remove the top element and then we popped it and we pushed it into the okay. If the mean size is more than the size of max heap, then in that case, remove the top value from the push it into the max heap, and then from min heap we try to pop it out. That's it. And here, if the min heap size is equal to the max size, and in that case, we are doing is let's try to do this. But now we'll check again. Yeah, now we'll try to submit it. Yeah, so it's working, and that's it. So the question is pretty simple. We just need to focus on the basic concept is required for doing any question, and that's it.